Hello and welcome to helpyourmath.com. In this video, we're going to look at the graphs of sine and cosine functions of the form g of x equals a times sine of bx or g of x equals a times cosine of bx. So just meaning we might see a change in amplitude and we might see a change in period. Before we get to transformations, let's review the parent functions. So the parent functions would be f of x equals 1 times sine of 1x or f of x equals 1 times cosine of 1 times x. The domain for either of these functions is all real numbers. The range is from -1 to +1. The amplitude is 1, and the period is 2 pi. So when we're talking about amplitude, right, these graphs look something like this. The amplitude is from the midline, so there's always going to be this midline. And when we're talking about the midline, every other key point that we talk about hits the midline. That midline on the parent function will be the x-intercepts, but the amplitude is the distance from the midline up to the top or the midline down to the bottom. So in either case, this is a distance of 1 and that's a distance of 1. The amplitude, we usually use a capital letter A to represent it, and we find that capital letter A in the transformations. So if we have f of x is equal to a times sine of bx or cosine, right? It doesn't matter if it's sine or cosine, but the way we find amplitude, if there is an amplitude different than the parent function, it's the absolute value of a. Its amplitude, it's always positive. And the period being 2 pi, so sine and cosine functions are called periodic functions, just meaning they do something and then they repeat that thing and they repeat that thing. For a sine graph, we usually start at the midline, and then we do one full period is when we go up to the top, down to the bottom, and back to 0. So it'll be one full period for sine. For cosine, we start up at the top, and then we go down to the midline, down to the minimum, back to the midline, back to the top, would be one full period for cosine. So sine is like this, and cosine looks like that. The way we can determine the period, if the period is not 2 pi, and this one's a little bit sneaky, how we determine the period. So it's this thing that's being multiplied within the function, within sine or cosine, and we would say that the period is equal to 2 pi divided by whatever is being multiplied to x. So in the parent function, it's 1 being multiplied to x, therefore the period is just 2 pi. Something else that's really important when we're graphing sine and cosine graphs is to recognize the 5 key points. For the sine graph, that's going to be the mid, the upper, the mid, the lower, the upper. So where those 5 points occur. For cosine, we start at the top, so we're at the top. We go to the middle, we go to the bottom, back to the middle, back to the top. And of course, if A is negative, then everything is reversed. It's going to reflect about the x-axis. So the 5 key points for sine starts at 0, 0. The next x value is pi over 2, comma 1 is the maximum. Then we go to pi, and then we go back to 0, 3 pi over 2 and -1, 2 pi and 0. And this should look familiar, right? Because if you plugged in sine for these x values, this is saying that sine of 0 is 0. This is saying that sine of pi over 2 is 1. So that should make sense, right? And if you think back to the unit circle about where these things are on the unit circle, this should be hopefully very clear. And then cosine, we start at 0, 1. We actually start at the y-intercept. Well, I guess they both start at the y-intercept, don't they? Then we go to pi over 2, comma 0, pi -1, 3 pi over 2, comma 0, and 2 pi, comma 1 is our final piece of cosine. One more important thing is, how do we determine the x values for the 5 key points? And that's a great question. How do we get those 5 values? Well, you'll notice here that we go from 0 to 2 pi. So one complete period is from 0 to 2 pi, which again, think back to the unit circle, that's one full circle. Now, if we tinker with this and we adjust the period and the period is no longer 2 pi, what we want to do to figure out the x values for the 5 key points, so we're going to call this the increments for the x values of the 5 key points. And what you do is you're going to take the period and you're going to divide it by 4. Assuming we're not going to see any sort of transformation, horizontal transformations, so we're always going to start at 0. And then to figure out the next one, you would do the period divided by 4, right? So if I did 2 pi divided by 4, I would get pi over 2, because that'd be 2 pi over 4, which is pi over 2. So to go from the first piece to the second piece, I would add pi over 2. To get to the next one, I would add pi over 2 again. So the increments between the x values are pi over 2. And again, as long as there's no horizontal transformation, which we won't see in this video, the final x value should match the period itself. Okay, this has been a lot of information. Let's look at quite a few examples, because I know these can be a little bit intimidating and we want to make sure that you're totally comfortable with them. We're going to sketch a graph, and we're going to include 2 full periods. Usually what I tell my students with these is you need to label 1 full period, and you can still draw the second one, but I want to see all of the x's on the graph when you sketch the graph of 1 period. So here we're given y equals sine 3 times sine of 2x. The amplitude here, remember the amplitude, that's the absolute value of a, which in this case is the absolute value of 3, which is 3. The period, to figure out the period, we do period equals 2 pi divided by b. Well, in this case, here's our b, right? So we have a is 3 and b is 2. So what we would do is we would do 2 pi divided by 2, and we end up with pi. So this time we have a period that's going to, 1 full period will end at pi. Now our 5 key points, we're going to label this x and y. And to figure out the x values, do you remember what we do? We look at the increments, and we figure out the increments. So increments are determined by taking the period and dividing it by 4. So that would be pi over 4 in this case, because our period's pi. And remember where we start? This is sine, so we should be starting at 0, 0, and a change in amplitude and a change in period is not going to change the starting position for our sine graph. So we're starting at 0, 0, which if it's helpful, write it as an ordered pair below. Okay, so then where are we going next? We're going to go where we're starting and add the increment to it. So 0 plus pi over 4 is pi over 4. What y value happens here? So remember our sine graph, we start at the midpoint, at the midline. We go up to the top, back to the midpoint, down to the bottom. That's what 1 period will look like. So we're going up to the top, but this time, how far up are we going? There's an amplitude of 3. So we're going to add 3 to 0, and that's going to tell us that top point. Now we're going to go to our next ordered pair. So this is the ordered pair pi over 4, comma 3. Next, we're going to add the increments to the previous x value. Pi over 4 plus pi over 4 is 2 pi over 4, which is pi over 2. And sine's going to go, so it went middle, top, back to the middle, so we're going back to 0. For the x's, we go to the last x coordinate, add pi over 4. Pi over 2 plus pi over 4. Pi over 2 is equivalent to 2 pi over 4. 2 pi over 4 plus pi over 4 is 3 pi over 4. So this one will be 3 pi over 4. What happens with the sine? It's going down to the bottom. So where's the minimum going to be here? With an amplitude of 3, the minimum's at negative 3. And last step, we're going to add the increment to this last x value. This is 3 pi over 4 plus pi over 4. That's 4 pi over 4. 4 pi over 4 is equivalent to pi. Remember what this final x is supposed to match? This final x is supposed to match the period, and it does, so I feel good that I did something right. And where does the y end up? It ends up back at the middle at 0. So there's 1 full period. Those are the key points, the middle, the top, the middle, the bottom, the middle, for 1 full cycle. When you go to sketch this graph, you have to be consistent with your grid. So if I go here for pi over 4, then I have to go here for pi over 2. I don't get to skip one and say, oh, I'm going to go over here because I need the space. That's not how this works. You have to be consistent with the increments, right? Each thing is representing the same amount, so we need to be consistent with that. So then here would be 3 pi over 4. And, I know why students skip it is because it gets a little bit squished in here. But that's why, if you're going to skip somewhere, you have to skip everywhere. And then for a second period, this ends the first period and starts the second period. So that's the starting. Here's going to be our max, back to 0, min, back to 0. So that's going to be the end of the second period, and that's going to end up being 2 pi. Okay, so now we're going to sketch a graph of these. Oh, I didn't finish my ordered pairs. Pi over 2, comma 0, 3 pi over 4, comma negative 3, and pi, comma 0. So 0, 0, we're going to start here. And now we have to decide what our y-axis is going to be. I think we just go in increments of ones. 1, 2, 3, -1, -2, -3. And then we're going to go pi over 4 up to 3, pi over 2 back to 0, 3 pi over 4 down to -3, pi back to 0. Pi is starting the second period. So next we will go up to 3, go back to the middle, down to the bottom, -3, back up to the middle. Nice smooth curves here. So it's whoop, and it should look something like that. So that's 2 full periods. Let's try this again. Okay, in our next example, we have -2 times cosine of x over 2. So this is a cosine graph. Cosine graph, remember, we normally will start at the top. So our parent function, I'm going to call that PF, we start at the top, we go to the middle, we go to the bottom, we go to the top. So we have the midline like right about here. In this case, A is -2 and B is 1/2. So if you take x out of the fraction in this cosine of x over 2, we would write that as 1 over 2 times x. Okay, so now this one's going to be interesting because we have the -a. The -a indicates to us that we actually don't start at the top, we start at the bottom. So in this case, our parent function, or I'll say our negative parent function, would be bottom, middle, top, middle, bottom. With our midline there, that's what this one should look like, since we have that negative in front of the function. The amplitude here, that's going to be the absolute value of A. The absolute value of -2 is 2. So that just indicates to us on our graph, the distance from the top to the middle is going to be 2, or the distance from the bottom to the middle is going to be 2. The period, so the period, we determine the period by doing 2 pi divided by b. So this is going to be 2 pi divided by 1/2. How many halves are in 2 pi? Well, this is the equivalent of 2 pi times 2 over 1, which is 4 pi. Okay, so our period is 4 pi. What are our 5 key points? We have x and y. Now, here's where things get a little bit tricky with cosine. Cosine should start at 0, 1, right? It should start at the maximum. But because we have a negative, we're starting at the minimum. And where's the minimum going to be? It's going to be at -2. So we're starting at 0, -2. We're starting at that minimum. And we get to kind of cheat because there's no vertical transformation. This is where we're starting, is -2 on the y. And again, if you are worried that you're going to mess this up, what is cosine of 0? Cosine of 0 is 1, and 1 times -2 is -2. So you can always double check with the knowledge that you already know what cosine of 0 is. Okay, what do we do next? We need to figure out our increments. So we have our period. To figure out the increments, we take the period and we divide it by 4. And when we do that, we end up with pi. So this time we have increments of pi's. Oh, that's nice. No fractions. So we're going to add pi to our previous x. That's going to give me pi. And then what I'm going to do is I'm just going to fill the x's across, just because it's kind of like it's a nice pattern. So when I add pi, I get 2 pi. I add pi, I get 3 pi. I add pi, I get 4 pi. And this should match our period. Our period was 4 pi, so I feel pretty good about that. Okay, now for the y values. So remember, we go from the bottom to the middle, and the middle is going to be 0 because there's no vertical shifts. To the top is going to be 2 because our amplitude is 2. So the amplitude should be the difference between the bottom and the middle and the top. We go back to the middle, we go back down to the bottom. All right, so now we have our key points. Let's sketch these on this graph. So we have 0, pi, 2 pi, 3 pi, 4 pi. I'm doing 2 periods, and since these are, I don't really have to think, I can just keep going here. And I'm going to stop at 8 pi. I start at 0, -2, so -2 will be down here. I go up to the x-axis. I go up to 2, back down to the x-axis, back down. So there's one full period right there. Now that's also the start of our second period. Second period, we're going to go back to 0, up to the top, back to our middle, down to the bottom. Nice smooth curve here. It's really easy to want to do something like this, but that's not what sine and cosine look like. So don't make sharp points, nice smooth curves. All right, you feeling good? You ready to try a few of these on your own? I thought so. Go ahead and give this one a shot, see how you do. Okay, so parent function, we're talking about a cosine graph, so that means that we start at the top, down to the bottom, back up to the top. It's almost like an upside down omega. And there's our midline. What information do we have here? We know that the amplitude, we know that A is 1 over 4 and B is pi. Now we can figure out the amplitude in the period. The amplitude is the absolute value of A, which will just be 1/4. The period, we determine that by doing 2 pi divided by B. So this will be 2 pi divided by pi. Ooh, look at that. We're in the rationals. We just have a period of 2. All right, now for our key points. Again, what I usually like to do with these is I like to figure out all the x's first, and then I figure out the y's separately, just because of the way the pattern works. So we know that we should be starting at 0, 1, right? And the parent function would be 0, 1, but we only go as tall as the amplitude. And so in this case, amplitude is 1/4, A is positive, so we're going to start at 1/4. Okay, now let's fill in the x's. So we need our increments. To determine the increments, we're going to take the period and divide it by 4. So we're going to do 2 divided by 4. We're doing increments of a half. So we're going to take a half and add it to each previous x value. 0 plus a half is a half. 1/2 plus 1/2 is 1 whole. 1/2 plus 1 whole is 1.5. And 1.5 plus 1/2 is 2. Does 2 seem right? Yes, because it matches the period, so I feel pretty good about that. Now for our y values, we're starting at the top, we're going to the middle, we're going down to the bottom, all the way down to 1/4, back to the middle, back up to the top. And now we're ready to sketch a graph of these. And remember, if you're ever in doubt, if you ever are concerned about your y values, this one's a little bit tricky. Well, no, it's not, because it's cosine of 0 is 1. Then you would have cosine of pi over 2 would be 0. Cosine of pi would be -1, right? So you can always use your knowledge if you get worried about these y's or anything that I'm doing here. There's so much that we already know about trigonometry that I know you can do this. All right, so what do we have? We have 0, and then I need a quarter. So what I can do is I can kind of cheat a little bit and say, here's 1 up here, which would make this 1/4. And then here's -1 down here, which would make this -1/4. If I, tried to squish it in here, it would look really, really squished. So I'm just going to kind of like use the axis as needed. And then here I'm going to have a half. This is 1. This is 1.5 or 3 halves. 2. This would be 5 halves. 3, 7 halves, and 4 for my 2 periods. So 0 and 1/4. It's going to be up here. 1/2, 0, back to the middle. At 1, we're going down to the minimum, going back to the middle, back up to the top for 1 full period. Starting the second period up top, we go down to the middle, down to the bottom, back up to the middle, up to the top. Nice smooth curve here. This one should be very squished because of that teeny tiny amplitude. Okay, one more example. Here we go. Y equals -2 times sine of 2 pi x over 3. So our parent function for sine should be starting at the middle, going up to the top, middle, bottom, middle. But because this one has that negative, the negative parent function, instead of going up first, we go down first, up, back to the middle. So remember, with sine, we start at the middle, we go up or down depending on the sign, go back to the middle, go up or down depending on the sign, back to the middle for that full period. In this case, A is -2, so that's why we're looking at this negative here. And B is 2 pi over 3. The amplitude is the absolute value of -2, so the amplitude is 2. The period is, what do we have here? We have 2 pi over B, where B is 2 pi over 3. So what ends up happening here is we end up with 2 pi over 1 times 3 over 2 pi. Ooh, and again, we get to work with nice increments here, so nice rational increments. Our period is 3. Next, we want to figure out our 5 key points. So remember, this is sine. Where does sine start? Sine starts in the middle. And the middle in this case is 0, 0. Let's fill in our x's. So to figure out the x's, let's look at our increments. We have increments of 3, the period, divided by 4. So we have increments of 3/4. We're going to take the increments, add it to our starting x value. 0 plus 3/4 is 3/4. Add 3/4 again. 3/4 plus 3/4 is 6/4, which simplifies to 3/2. 3/2, which remember was 6/4, so we're going to use 6/4 because that matches our increments here. 6/4 plus 3/4 is 9/4. And lastly, 9/4 plus the increment 3/4 would be 12/4, and 12/4 is 3. Do we feel pretty good that we ended at 3? Yes, we should, because our period was 3. Hooray! For the y values, because a is negative, remember we're going down first. So how far down are we going? We're going 2 units down to -2. We're going back to the middle. We're going up to the top, ending back at the middle at 0. Let's look at this graph. So I need to label here. I'm just going to use 1, 2, -1, -2. Here I'm going to use 3/4, 3/2, 9/4, 3, and then we're just going to do a second period, which I don't necessarily need to label, but you can if you want to. It'd be, what do we have, 9/4, 12/4, so 15/4, and then 18/4, and then 18 plus 3 is 21/4, and then 24/4, so it should end at 6. Okay, so what do we have? We have 0, 0, 3/4 down, back to the middle, back up to the top, back to the middle. Then second period, we go down first, back to the middle, up to the top, back to the middle. Nice smooth curve here. It's coming from the top. Whoop, oh, I missed. Oh, sad day. Back up, down, up, and back to the middle. Whew, we did it. These have been examples of looking at sine and cosine graphs when we have different amplitudes and periods than our parent functions. Thank you for stopping by.